Welcome to our channel. Today, we're diving into Einstein's theory of relativity and exploring how it could lead to time travel. Buckle up, because this is going to be a mind-bending journey. Einstein's theories weren't just abstract equations, they were radical new ways of understanding space and time itself. One of the most mind-blowing implications of relativity is that time, as we experience it, is not a constant. It can be stretched and squeezed, opening up the tantalizing possibility of time travel. One of the most well-known predictions of Einstein's special theory of relativity is time dilation. It says that time moves slower for objects moving at high speeds relative to a stationary observer. Imagine a super-fast spaceship traveling at a significant fraction of the speed of light. According to Einstein, time inside that spaceship would slow down relative to someone on Earth. So, if you were to hop on this spaceship and take a quick spin around the galaxy, you might only age a few years while decades or even centuries pass back on Earth. You'd essentially be taking a one-way trip to the future. We've observed this phenomenon with atomic clocks flown on jets. The clocks on the jets tick just a tiny bit slower than their counterparts on Earth, confirming Einstein's predictions. Building a spaceship that can travel at near-light speed is a challenge, but the implications of time dilation are truly mind-boggling. Imagine future generations embarking on interstellar voyages, returning to a vastly changed Earth centuries later. Now let's talk about wormholes. Imagine folding a piece of paper in half so 2 points touch. That's essentially what a wormhole is, but instead of a piece of paper, it's space-time itself being folded. These theoretical tunnels could connect two distant points in space-time, allowing for instantaneous travel between them. Think of it like taking a shortcut through the universe, bypassing the vast distances between stars and galaxies. Einstein's theory of general relativity allows for the possibility of wormholes, but they remain highly theoretical. We haven't observed one directly, and creating one would likely require manipulating unimaginable amounts of energy, perhaps even exotic matter with negative mass. But let's say, just for fun, that we could create a wormhole. Could we use it to travel through time? Some physicists think it might be possible. Now let's delve into the realm of cosmic strings. Imagine a thread so thin it's smaller than an atom, but stretching across the entire observable universe. That's a cosmic string, at least in theory. These hypothetical objects are thought to be remnants of the very early universe, like wrinkles in the fabric of space-time itself. Cosmic strings are thought to possess immense density and gravitational pull. According to Einstein's theory of general relativity, massive objects warp the fabric of space-time around them. If you were to harness the gravitational energy of a cosmic string, you might be able to create a closed, time-like curve, allowing for time travel. Picture two cosmic strings passing close to each other, potentially warping space-time so dramatically that it creates a loop, allowing you to travel back in time. Now let's talk about the rock stars of the cosmos black holes. These gravitational behemoths are regions of space-time where gravity is so strong that nothing, not even light, can escape. But what makes black holes fascinating in the context of time travel is their ability to warp time itself. According to Einstein's theory of general relativity, the stronger the gravitational field, the slower time moves. Imagine you're an astronaut approaching a black hole. As you get closer to its event horizon, time for you would start to slow down relative to someone observing from a safe distance. To them, you would appear to be moving slower and slower until you eventually disappear from view. But from your perspective, time would seem to tick normally. If you were somehow able to survive the journey into a black hole, some physicists believe you might emerge on the other side, potentially in a different point in space and time. Now, for our final act, let's explore faster-than-light travel, or FTL. According to Einstein's theory of special relativity, nothing can travel faster than the speed of light. But what if there were a way to cheat the system? Enter the concept of warp drives, a staple of science fiction. The idea behind a warp drive is to cheat the cosmic speed limit by warping space-time itself. Instead of traveling through space, you would be riding a warp bubble, a region of space-time that contracts in front of you and expands behind you, propelling you forward at incredible speeds. The concept of warp drives is still highly theoretical, and it would require exotic matter with negative mass energy density. But some physicists believe that warp drives might be possible within the framework of Einstein's theory of general relativity. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content. Let us know in the comments which of these time travel theories you found most intriguing. Remember, the universe is a vast and mysterious place, full of wonders waiting to be discovered. Keep exploring, keep questioning, and never stop looking up at the stars. Who knows what incredible secrets we might unlock in the future?